we have divided all the modules. Oh, for some reason, I don't know why, but things used to be called chapters, and then they were called units, and now they're called modules. I don't know why. So we're going into module 1, and this is lesson 1.1, which means the first lesson in module 1. This should all be review. And there are 8 topics in this lesson. However, if you passed a topic off when you did the knowledge check, it won't show up here. So maybe some of you already have 100% on this lesson. I don't know. At the end of every module, so we'll do 1.1, 1.2, 1.3, and so on. At the end of the module, it will force you to do a knowledge check. Yes, you have to do the knowledge check, and if you wreck the knowledge check, it will go back and delete topics from the assignments that you've already finished. So when you do a knowledge check, make sure you do your best, because if you don't, then you got to go back and redo those topics, or it's going to hurt your grade. Does that make sense? And then after that knowledge check, we will do a practice test, and then we'll take a test. So this lesson deals entirely with graphing. So here's my function, negative 3x squared. So I recommend that you build a table. Well, actually, I think you can just, oh, well, let me use a calculator on this one. So the vertex of a quadratic is going to be at negative b over 2a, comma, whatever the y value is. So how do we graph a quadratic? Well, first we need to figure out where the center is. So the center for a quadratic is called the vertex. So in a quadratic, we have ax squared plus bx plus c. And the x coordinate of the vertex is at negative b over 2a. So in this case, a is negative 3. What's b? What's the b term, the b value in this quadratic? There isn't one, right? This equation is negative 3x squared plus 0x plus 0. So there is no b term, and there is no c term. Negative b over 2a is going to be 0 divided by 2 times negative 3, which is 0. The vertex of this quadratic is 0 comma something. How do we figure out what the y value is? Well, if we know the x, we just plug it in to find the y. So I'm going to stick this in here. Negative 3 times 0 squared is 0. So the vertex of this parabola is 0, 0. Right there. Okay? Now, once we know the center, there are 2 ways to graph it. A normal quadratic, x squared, has this pattern. Over 1, up 1, over 1, up 1, and then over 2, up 4. 1 squared is 1, 2 squared is 4. So 1, 2, 3, 4. Over 2, up 1, 2, 3, 4. What if I went over 3? How far up would I need to go? 9. Okay? So that is a basic quadratic. Over 1, up 1, over 2, up 4, over 3, up 9, and so on. What is this negative going to do to my parabola? Flip it upside down. So now it's a frowny face instead of a smiley face. What is the 3 going to do? Triple the height. Or in this case, the drop, right? So normally I would go over 1, down 1. But in this case, it's going to be over 1, down 3. So over 1, down 3, over 1, down 3. And then over 2, So it's normally over 2 down 4, but in this case it's going to be 12. So over 2 down 12. Over 2 down 12. And then once you have to draw the vertex, and then you have to do 2 points to the left and 2 points to the right. And once you have that, you can push this button and it will draw the graph for you. Okay. Now there's another way to do it. If you know where the vertex is, then you could just start plugging in numbers. So if I know that the x value of my vertex is 0, then I know I need to plug in 1 and 2. So I plug 1 in there. Just build a table. So x and negative 3x squared. 0, 0. Plug in 1. 1 squared is 1 times negative 3 is negative 3. Then plug in 2. 2 squared is 4. 4 times negative 3 is negative 12. Plug in negative 1. Negative 1 squared is 1 times negative 3 is negative 3. And when I plug in negative 2, I will get negative 12. Both ways will work. So you start by finding the vertex. Once you find the vertex, you either plug in numbers on the sides or you just follow the pattern according to how to graph a regular quadratic. So let's do my quadratic is 2x squared. So negative b over 2a. What is b in this case? 0. So negative 0 over 2 times, what's a? 2. So negative 0 over anything is 0. How do I find the y-intercept? Or sorry, the y value of the vertex? Plug that in, and I get 0. So here the graph is 0, 0. Normally I would go over 1, up 1. But instead I'm going to go over 1, up 2, because it's twice as tall. Negative 1, up 2. And then normally we go over 2, up 4. But in this case it's going to be over 2, up 8. Over 2, up 8. And then draw the parabola. Any questions there? Negative b over 2a. In this case, it's negative 0 over 2 times negative 1, which is 0. So the x coordinate of my vertex is 0. What is the y coordinate? We plug that in here. 0 plus 2 is 2. So this vertex is at 0, 2. Right there. How does this parabola open? Down. Is it taller than normal? No. It's the normal shape, but it opens down. So over 1, down 1, over 1, down 1, over 1, down 4. Over 2, down 4, over 2, down 4. And that's my parabola. Okay, same thing there. How about this? Maybe we should do the next one first. Let's do the next one, and then we'll come back to this. Okay. Where is my vertex? The x value of the vertex is always negative b over 2a. In this case, that would be negative 2 over 2 times 1. So that's negative 2 over 2, which is negative 1. So my x value of the vertex is negative 1. How do I find the y value? Plug negative 1 in there. Negative 1 times negative 1 is 1. 2 times negative 1 is negative 2 plus 5. That gives me 4. The vertex is negative 1, 4. Right there. How does this parabola open? Up. Is it a different shape from a normal parabola? No. It opens up, and it's just a regular parabola. Over 1, up 1, over 2, up 4. Over 1, up 1, over 2, up 4. Do you want to see another one of those? We're good? Okay. This is called standard form. It's sort of hard to graph an equation in standard form. The other form is called vertex form, and it's really, really easy to graph. In fact, we don't have to do any work. We just have to graph it. So this is vertex form. A normal parabola is x squared. Okay? There are things we can do to this. We can move the parabola side to side. And we do that inside the parentheses underneath the squared. We can move the parabola up and down. And we do that by adding stuff onto the end. We can also flip a parabola upside down, or we can change how tall it is. And we do that by multiplying a number in the front. Okay? So, stuff that happens on the inside to the x shifts it left and right. Anything that happens outside affects the y values. So the k moves it up and down, and the a can flip it upside down. It can also change how tall it is. Notice, the x-axis is backwards. So this is saying x plus 2 squared. You would think adding 2 would move it to the right, but the x always works backwards. So this vertex is going to be left 2 and up 1. Left 2 and up 1. And then it's just a normal parabola after that. Oop, I missed. Like that. Do you guys remember this? So what if we had negative 4 x plus 1 squared minus 3? Does the order you perform these transformations matter? Yes, it does. The reflection does. You start on the inside and work your way out. So what is this telling me to do? Left 1, so I'm going to move to here. What is this telling me to do? Opens down, and it's 4 times taller. So we start with this parabola. We move it left. We have this parabola. Now we move it. We flip it upside down, and we make it super duper steep. And then we subtract 3. So we move it down 1, 2, 3. And we get this. Okay. If you do it in the wrong order, if you go down 3 and then reflect, so if we go down 3 and then we reflect across the x-axis, then we're going to get this, which is wrong. So the order of the transformation does matter. You start on the inside and then work your way out. It will work, but on something more complicated, it might not work. So just get used to starting with the x and working your way out. In this case, that would totally work, but that's technically not the right way to do it. But in a lot of instances, it'll still turn out fine. What if we had 1/2 x squared? It's wider, and it looks wider, but we're affecting the outside, right? So anything on the outside has to affect the y's. So it does look wider, but technically it's shorter. So what you would do is Normally, you would go over 1, up 1, but instead you would go over 1, up 1/2. How would you graph 1, 1/2 when it won't let you put a point there? You use this. If you want to put a point somewhere other than the intersection of the grid lines, then you just have to click that little button and it'll say, where do you want us to draw a point? And then you would draw it. And then the next one would be over 2, up 4. We cut that in half. And so it looks wider, but really what we've done is made it shorter. So this one would be 3. Normally it's 9, and now it's down to like 4.5. So there is a way to graph a point that's not on the intersection of one of the grid lines. Not. Okay, I think that's it. All right, 1.1, get to work.